I'm Jiri. I work in Databricks from November 2017, and today I'd like to tell you something about Spark, Databricks, and finally how to use those data tools to solve a crime. First, why we chose this topic? Why we are talking about Spark and Databricks? The first reason is that we think that those tools are really cool. Within the projects I'm working on in Databricks, we use Databricks on a daily basis. But there is additional reason, and that's the Databricks is planning to make a hackathon after the summer. So this is also to advertise this hackathon. And for this hackathon, knowing the Databricks and Spark is kind of a prerequisite. So this is also to tell you some introduction to those tools if you don't know them yet. Okay, so first a few words about Spark. Spark is an open source tool, and the purpose of that is to process big amounts of data. And what is very important, it can process those big amounts of data on clusters, on multiple computers. And it can do it with very small effort from the side of the developer. So basically, you don't have to care much about how the data you are processing are divided between those nodes within the cluster, how they are moved among the clusters. Spark pretty much does this automatically for you. Sometimes Spark is seen as replacement of Hadoop. There are a lot of measurements that show that for certain tasks, Spark is much faster. How Spark is doing it? Basically, the very important term is resilient distributed data set. This is an abstraction you can use as a programmer, where the data set is actually, as I said, distributed among multiple nodes. But within your code, I will show you later, it looks like that's a normal sequential program. You actually even don't see directly that the processing is happening on multiple nodes. For doing the programming in Spark, you can use several programming languages. The examples I'm going to show you today are all written in Python, but you can also use Java or Scala. Now something about Databricks. While Spark is an open source project, Databricks is paid. And the main idea of Databricks is to give you some more features, like more libraries for processing statistics, for showing graphs, and so on. But also to save some work in managing the Spark. Because still, even if it's kind of easy for the developer to write the Spark programs, it's not that easy for the guy who has to maintain the data center. So the Databricks company basically provides you with Spark in the cloud, and you don't have to care about the maintenance of your machines. So this is why we use Databricks. Currently, Databricks supports both AWS and Azure. Supporting Azure is quite a new thing for Databricks. And you can actually use it interchangeably. The scripts doesn't need to be changed if you want to move them from one cloud to another. Now I'd like to tell something about the data formats you can process in Spark. You can process pretty much everything you can imagine, because for most of the formats there are libraries available. The most common data sets, of course, are JSON, Parquet files, CSV, but also Spark can access the relational databases, so you can connect them to the old relational world as well. About data that are not stored in relational databases, again, you can use a lot of different storages. Of course, you can use S3 or the Azure blob storage, but also some other technologies are supported. And as I already said, Spark and Databricks support a lot of libraries for the common tasks. So you can use SQL queries, you can use libraries for streaming the data, for graph computation, statistics, and also for machine learning. A new thing in the Spark world is support of the TensorFlow, which is the Google library for neural networks. So also this one is now supported by Spark and Databricks. I don't want this presentation to be just talking and showing the slides. I prefer to show you hands-on working with the Databricks and also some code. So this is just the first view of how the Databricks user interface looks. The basic abstraction here is called a notebook. Notebook is a series of code pieces that you can interactively change and run. Also, there are the ways how to show the data within this notebook. So, if you look here, this first part of the page is just 3 lines of the Python code. This code is very simple. It actually just loads some data from the cloud storage to the memory. And the second part of this page is actually 1 line. It's just this statement that says to display the data that was previously loaded into memory. So this way you can just show the data that was loaded. The examples I'm going to show today are not working with too big amounts of data to make the examples simple and also to make the processing not that long. But what is important if you use Spark and Databricks is that if this data was too big to fit in memory of a single node, Spark will automatically distribute it among several nodes. And you, in this notebook, still works with the data using the single identifier. So you would even don't know that it was distributed automatically. So this is about the notebooks. Another important abstraction in Databricks are the clusters. I will not tell too much technical details because we don't have that much time, but here is the list of clusters that are defined within my Databricks instance. And very easily, you can set here the properties of the cluster. What is especially important that you can configure the number of nodes that will process your data. So once you have some understanding of how big amounts of data you want to process, you can set up the cluster properly, and also you can use auto-scaling feature. In that case, the number of nodes is automatically chosen according to what is the amount of data you are going to process. Usually, the Databricks is used for interactive work with the data. So it's usually like you load some data, do some queries, immediately show some graphs or some results of the queries. But it can be used not only for this interactive work, but you can also use Databricks for planned jobs. So you can predefine when and what type of code should be run on the data and run something on a daily basis. So it's also suitable for this more like production environment, not only for the analysis. Okay, so this was kind of very brief introduction into the Databricks and Spark, and now I would like to show you some of the features Spark provides on an example. So for this example, I chose a story written on the blog of Andrew Murray. He is an analyst, a data analyst, working for FBI and other institutions. So he's really doing data analysis to solve crimes. Of course, this story is kind of simplified, so it's not real data. It was actually used for the investigation, but it's inspired of the work that is really done by the investigators. So the story is like that. There was a series of burglaries in a hotel, and there's a theory that the stuff was actually stolen by the employees of the hotel, either internal or external, because no locks or doors were destroyed. Each room something was stolen from was accessed using the card. So the question is, how could we, using analysis of data we have about the cards, about the things that are happening in the hotel, how could we identify the person that is the suspect? There is the second part of the story, because the things that are stolen appeared in the pawn store later. So again, we can ask how to use some databases the police creates about the stolen things to identify the person who put the things in the pawn store, because it turned out that it was not the person who stolen it from the hotel. So there are like two thieves actually, not one. So let's think about what data sets we could use to do the analysis here. First, we have the data from the electronic key system log, which is the system that logs entrance to every room in the hotel. So every guest and every employee that wants to enter the room has a card, and the access is logged here. At the same time, another database is being created, and it's about how the cards are assigned to the persons, because the cards are recycled, of course. The third database we are going to use is called incident report database. It's basically the recordings about what was stolen from what room, at what time, or approximately at what time. And the final data set we are going to use here is the pawn ticket database. Again, this is the record of what person bring what things into the pawn store at what time. So what I did, I created those data sets. Can you read it, or should should I increase the font a little bit? Yeah, okay. I created those data sets and stored them in the Azure Blob Storage. So actually this shows how easily Spark and Databricks can access various data sources. The format of the data in this case is JSON. So it's a series of the lines in the text file. Each line is a valid JSON code, and the schema of all of those lines is supposed to be the same. I can actually show you. As an example, I can show you one of those files. So it looks like that. On each line there is a JSON somehow expressing one report or one event. As you can see, to load this into Spark, you actually don't need to do any parsing of the data. Spark already knows many data formats, so by this single line of code, just providing the fact that this is a JSON, you not only load it into memory, but also you parse it. So in the subsequent block of code, just by the command display card ownership log, it shows the data in the form of a table. So this is what we have for the card ownership log. So this is the card number, this long string and the identifier. Then we have the name of the person who the card was assigned to. Then we have the time from which and to which the person was using that card. So this is the first table we are going to use for the analysis. The second table is the electronic key system log. Again, here there is the card number and the time, the date and time, and the room number that was accessed using that card. Again, just by a single command, I can display this table. If I was showing some numerical data, I could just by a few clicks choose to display it not in the form of the table, but instead in the form of some graph. But it's not suitable for this type of analysis. So I will stick at the tables here. And finally, we have the incident report database. So again, it says that that something was stolen from this room number before and after this time, because of course we don't have a precise time of such an event. Just the person who stays in this room knows that he or she left at the morning and returned at the evening. So sometimes between those two times, the thing was stolen, and we have it's called stolen subject description indices. Basically, there is a database that is being created by cooperation of the hotel, the police, and the bone storages. When something is stolen, the hotel sends the description of the stolen things to the police. The police sends it to the pawn stores, and then they check whether they have something that matches the description, and if it does, they put a record into this database. We actually, for this analysis, don't need the whole database with all those descriptions. What we need is just this ID. So this somehow identifies the stolen thing. And the same ID is being used in another table that is for the second analysis. So for this first part, we still don't need it. I will talk about it later. So what we want to do now, we know when a person is accessing the room, we know how the cards are assigned to persons, and we know when something was stolen from a room. So we can somehow now join those three data sets together to get some suspects. This first part of the analysis code is registering the data sets are loaded into memory or memories of more computers as a database, as a table. It's an abstraction that is needed if you want to access the data in those data sets using SQL. The thing is that a Spark provides you with the options to use several approaches to do the queries or do the analysis on the top of data. One is using the classical Python code. The Spark framework provides a lot of methods that you can call on the dataset objects to do filtering, to do deleting some records, and so on. But there is another approach that I am going to use today because it's actually easier. Instead of doing the analysis as a series of modification statements on the datasets, I will register the whole dataset as a table, and then I can use the SQL language or something that is very similar to the normal SQL language you know to do the queries. Again, my datasets are very small, but the advantage of Spark here is that if the dataset is very big, it's automatically just distributed among the nodes, and even the complicated SQL queries are then automatically run on the whole cluster. So let's look at this first query. Basically, it joins the incident report database. This is the information about what was stolen from what room, and it joins it with the key system log. So here we join on the room number. So we want to find the pairs where the room is the same from the record describing the stolen things and from the record describing that somebody accessed the room. But it's not enough because rooms are accessed by many people, by the guest himself, by the hotel employees, and so on. So to provide more precise information here, we also have this additional condition that the incident has to that the room was accessed between those times that were specified in the incident report. And at the end, we order the things, order the result by all those data columns. I think it's a good time to let you ask the questions. If there's something unclear in this, because actually I don't know, for example, how much you are familiar with the SQL language. So whether I should provide more details about how this query is working, or whether I should move on.
What is red thing after where?
After where? This?
There is some red thing.
The red thing is cursor, yes. Well, actually that's a good question, because that's a cursor of, but it's not like my cursor, it's cursor of another user. Probably one of my colleagues who are still logged in the office to their computer. Because one of the advantages of those notebooks in Databricks is that you can share them with your colleagues, and you can even simultaneously edit the same notebook. So to exchange the work, it's really suitable. So the question was about the cursor, but not about this line of code. Okay. Yes.
Would it be better to get the cards which belongs to the guests, perhaps, and use just the cards which belongs to the employees?
Actually, I did in the data set. When I was generating the data set, because this is what I hope I mentioned, and it's written on the slide, that there is a theory that the things are stolen by the employees. So what I actually did, that I filtered out all the card membership records of the guests. I keep only cards of the employees, but in the room access data set, I have all of them. But it's automatically filtered out by this join, of course. So the data is not there anymore. So the result that you can see here contains actually only the cards that were held by the employees. But still, this is not the final result of the analysis, of course. We haven't used yet actually the card ownership log. So sorry, this is the one that was already filtered out. So now in the next step, I will do the filtering we were talking about. So this is just to remind you, showing what's the structure of the card ownership log again, and here we have the final query. This line is just to register. This line is just to register the intermediate result as a new table, so that again I can use an SQL query with this table. And this is the select statement that takes the intermediate result that was about joining the entry logs with the incident logs, and now it joins with the card ownership log. Here the condition is that the card number in the ownership log has to be the same as the card number from the data about entering the room. And again, also because the card is not assigned to a person forever, but only from some time to another time. Also, there is an additional condition that the incident happened between those times of card ownership. And here we have the result. And as you can see, because the data was generated for the purpose of this presentation, so the only person that resulted here is Kamal Hans. Of course, in reality, if I had more data, there would be probably also some other persons appearing here. For example, the other employees that entered the room, even if they didn't have anything in common with the stealing the things, they were just there to do the work. In that case, an additional analysis would be needed, like counting those lines and then take a suspect, the person with the biggest number of points or something similar. But here I wanted to keep it simple, so we have like the thief here, and it's kind of pretty clear who did it. Are there some questions about this? Yeah?
So it's about identifying what data sets will be used for a goal, right? And then somehow interpret them in the way that we can join them.
Yes. So I just want to say that it's not only about joining data sets. You can do much more with Spark. So you can actually run very complicated very complicated queries. Also, you don't need to load everything at the same time and do the whole analysis. What we actually do in Vistaprint a lot, that we use a pipeline of the jobs. Each of the jobs is doing some portion of the work, some filtering, some joining, some analysis, and then it stores the result into the cloud storage. And there is another job that is doing another piece of the work. So again, in this limited amount of time, I'm just showing very small part of what Spark can do. But in principle, you are right. Always the analysis is about first identifying what data sets you can use for your purpose, then asking whether you can load it into Spark without any modifications. And as I said, Spark provides you with a very good selection of the libraries to load the data, but it can also happen that you have some very specific data format that is not supported, but there are the ways how to write the loading routine yourself in any of those languages supported by Spark. And then you do the queries and the analysis, and as an option you can store the results back into cloud. Yes?
If you have a database that you cannot load into Spark, is there a way that Spark can communicate with another platform?
Yes, Spark can communicate, for example, with relational databases, or there is actually much more type of databases supported. In that case, you can do external queries. So it's not, but in this case, you can, of course, use the ability of Spark to load the data into memory of more nodes. Of course, in this case, the processing happens in the external database on any platform, and at the end, you get the result that is then loaded into Spark. But yes, you can do that.
If you run one external source, like the external relational database, and one source from the cloud of this one file, and when you join the data sets, where you join Spark will get all the data to the cloud and join in Databricks.
If you communicate with external databases, to do the join, you have to first get the data from the external database to Spark. So the answer to the question is the join happens in Spark. So first, if I understand correctly, you want to join, for example, a result of some query that was running in the relational database. So first you run this external query. Spark can just call the relational database, get the result of this query, loads it into memory. It also loads the additional data that are stored in the storage, and the final join happens in Spark. Did I answer the question, or? Yeah.
If the external query should do some rotation in external database, for example, all the code will be on the external source. For example, some cases, in my system, for example, sometimes we have a situation where we get all the data to one point and then join. We're not using the
You can do that as well. It's actually up to you. You definitely have both options here. So either you run an external query by sending the query to the external database, getting the results, and then working with these results in Spark. And another option is to get the raw data from the external database, load them into memory, and work them.
If you ask a question, please speak to the microphone. As I said, we're recording everything. will use it against you. I'm kidding.
So, as I said, I have one more example for you. This one is actually smaller.
Excuse me.
Yes?
What about the other guy? Because I sense that you didn't use the Polish database at all, and you told us there were two guys, one who stole it and second who sold it.
Yeah, this is actually in the second notebook.
Okay.
I was going to present right now.
Maybe I'm just confused. So, which is the Databricks part? You converted to Spark part?
Okay, everything you see is Databricks. So this user environment running in the browser is the Databricks platform. Spark is the backend that is being used for this platform. So all those notebooks, jobs, if you define them, configuration of the clusters, all of this is Databricks. Spark is different. That it's you can install Spark on your machine locally. You can install Spark in your data center. For Databricks, you have to subscribe for either the Azure Databricks or the AWS Databricks. So the Databricks company is using actually one of those clouds to run the clusters, but you actually don't need to know about it. You just use this user interface to work with that. Okay, so this is to answer your question. This is the second part of the analysis. Because if you think about it, to find the first guy who was stealing the things from the hovel, we really needed just to use those first three tables. Now we will use the incident report database again, showing that something was stolen from some room, but this time we will really also look at what exactly was stolen. And we will join it with the pawn ticket database, showing what things appeared in the both stores. So again, the first part is just registering those data sets so that I can create a query on the top of data stored in the data set. And this is, again, just to remind you what actually is contained in the data sets. What is interesting here, this is the incident reporting that during one incident there can be more things that are stolen from the room, not only one. So this is why here there is not one number, but in general there is an array of numbers identifying the stolen things. And this is the second data set we are going to use. This is always the name of the person who brought the thing into the pawn store, and this is again the identification of the thing from that stolen things database. Now the thing is a little bit complicated because to do a database join, it's difficult to use the array in that last column for the join. So the first thing we do here is it's called exploding the table. Basically it means instead of having one line with array, we will have two lines, and in each case there will be different number in an additional column that we created by the explosion. Please don't be confused that for reference we also keep this original array, but we will not use it for the join. That's just for the reference. Well, and after we exploit the table, we can do the final join. So again, here the condition to join on is that the ID of the item is same in both the records, and this way we connect the person who came to the pawn store with the incident in the hotel. And as you can see, in most of the cases, the person who brought the stolen things was Jonathan Simmons. There is one exception here. This is actually just to demonstrate what's the meaning of this stolen subject description index. It doesn't mean that it's like unique identification of the thing. For example, if two mobile phones of the same type appear in the pawn store, they will get the same index because the description of those is the same. And this is also why there is this additional name in the result. But again, if we count how many times each name appears, it's quite clear who's the thief here. Questions?
The table contains two columns with the same name, room number, and this table.
Okay.
If you
I will scroll to show the lines you are referring to.
row number, this one, and three columns to the right.
Same number.
The name of the column.
Okay, the name of the is room number, yes, and
you have another column name with the same name.
okay.
Room number.
Yeah, it's because the room, but it should be equal. It should be equal. It's because those two columns are actually showing in the table from those two joined data sets. I didn't filter it out properly. It's because, basically it's because, yeah, it's because the star here in the selection, I think. If I delete it, yeah, now it just lands there.
So basically it doesn't have any prefix showing which room number is from which table. So the name of the table don't.
In the table itself it doesn't. But of course in the code, in the query itself you can refer to that. And you, of course, if you, for whatever reason, if for example you are not joining on that column, so it could happen that the value of those two columns is different. In that case, you can use renaming to show two different column names to distinguish between those two. So you have it under your control. This was just like the default behavior of the query.
Okay. And another question: on the top of the notebook, you have the name of the notebook, which is tool.
Yes.
And next to it, it's the name of the language, Python, right?
Correct.
Does it mean that you can write only in Python everything what is written in this notebook, or?
It's a little bit different. Yes, for each notebook there is some default language defined. So as I said, you can write either in Python or in Java or in Scala. And for each notebook, you should provide a definition. Most of the code in this notebook will be in this language. And this is the meaning of the word Python here in parentheses. However, you can use special command at the beginning of a section to use also code in different language in the same notebook. So you can combine them. Just if you want to use different language than the default one, you have to explicitly state, now there will be code in Scala. It's the command here is, I think, it's percentage sign and the name of the language.
And this Python is fully functional. It's conventional Python and all the libraries which are available for it.
Yes, it's conventional Python. Also, you can install on the cluster any, for example, additional Python libraries you created. So if you created some special Python libraries in the form of an egg file, for example, you can also very easily install them on the cluster and use it in your notebooks. So there is really no limitation about Python libraries you can use.
And perhaps very last question.
Yes.
You, in the beginning of the presentation, you mentioned TensorFlow is the new feature of Spark, right?
Yeah.
And the TensorFlow is available through Python? Like Python library, or it can be accessed also through Scala or
Honestly, I don't know those details. As I said, this is a really new feature, like support of TensorFlow within Spark and Databricks, and I haven't tried that feature yet, so I don't know. I suppose it should be supported in all those languages, because this is the usual way in Spark. If you support some feature, you support it in all those languages, but I really don't know the technical details here.
Thank you.
There is any analysis in this data, and how did you deal with it?
Yes, that can be null, unfortunately. And yeah, you can. There are certain constructs that you can use in the queries. You can compare the value with the null identifier.
The SQL language is like full SQL language. It's not just something simple. You can use almost all the classic commands.
Yes, you can use. It's probably not that advanced as, for example, SQL language you use for MS SQL Server. But yeah, most of the common SQL constructs are available there.
Thank you.
What else can you use? Just not just SQL. What else can you use for mining the data?
What else you can use? First, you can use the libraries that are provided with Spark. For example, you can use some machine learning libraries, so you don't need to write all the details of the queries. You just reuse one of the machine learning methods that are supported within the library. Also, if you are not talking about libraries, but about really writing the code yourself, you still can, instead of this SQL queries, you can use Python, because Spark provides you with several methods to modify the data sets. One of the first things that I should mention here is the map reduce paradigm. So yeah, you can use the map and reduce methods on the distributed data sets. You can use also filtering. You can use some types of aggregation directly in Python without registering the data set as table and without using the SQL syntax. I'm not sure whether I answered the question, but I don't, unfortunately, I haven't prepared examples of that.
Maybe one really stupid question: is there any IntelliSense when you write SQL queries?
I don't think so.
Okay, thank you.
On the other hand, but about writing the code in Databricks, the first idea of Databricks probably was to provide the data scientists with some tool where they can interactively do the analysis. But you don't have to use this environment, of course. You can use any text editor, including some IntelliSense support, and later import the code into the Databricks. For the project we were working on the last few months, we actually also implemented some in CI/CD integration, so we don't have the code in the notebooks. We have it in the Git repository, and we have the CI/CD pipeline that deploys the newest version into Databricks. Databricks provides API, the REST API, that you can use to create the jobs, create the notebooks, upload there the Python libraries or any libraries you created. So you have a lot of control, even if you want to use those features from some external tool.
So as far as I understood, there is already an API for defining the job, creating the jobs?
Yes, there is an API, there is a REST API for creating the job, which means defining the features of the cluster and defining the notebook to run. And there's another API call that starts the job.
Okay, and to get the results.
Sorry?
And also to get the results from the job.
To get users?
The results.
Yeah. Yes. However, if I look at it from the point of view of this REST API, the result of the job is actually very small amount of information. It's just whether the job succeeded or whether it failed with some error. If we talk about the results of the computation the job is doing, usually it's not being loaded through this API. The usual approach is that the job stores the results in some cloud storage, and you can get the results from there.
Asynchronously.
Yes, asynchronously.
Okay, thank you.
Okay, I will keep in mind. I think this is all the examples I prepared for this presentation. So, if there are no additional questions, either about Databricks and Spark or more general, we can discuss in more general the area of big data and, of course, fighting the crime. Okay, in this case, thank you for your attention. Please provide us with the feedback, and also please follow the Proud Software Craftsmanship meetup page, because as I said, we plan to make a hackathon after the summer. So if you want to, you can apply for that. The idea is that the hackathon will be about Spark and Databricks. That there will be some tasks to solve using those tools.